Hello everyone. My second subtopics of my topic, which is the power. I'm gonna talk about the transmission and distribution. Uh, First of all, I'm gonna talk about the primary electric power transmission and the secondary electric power transmission. For the primary, high voltages of order 66 kV, 132, 22 kV, 400 kV, which is very high voltage. Uh, these are used. These value are used. Uh, the 66, 132, 22, 20, 220, and 400. They use for transmitting like power by three-phase wire overhead system. This is for the big supply substations usually. Uh, for this for the secondary electric power, this works for the smaller voltage, smaller than these, which is for 3.3 kV, 11 or 33 kV. These are the numbers. This is what most like substations they use. These are like fixed, like standard numbers. Uh, Here's the difference between primary electric power distribution and secondary electric power distribution. For the primary, the transmission lines or the connectors terminals are large main substation from which the power is distributed to small secondary substations scattered throughout the load area. The voltage may range here. Check this number for the the primary power distribution. The range is from 11 kV to 132 kV. For the secondary one, uh, this consists of should be low voltage network lie along the streets. The secondary one for the uh, streets or rural areas. From these sources, connections to individuals customer are provided. The circuits are used uh, for this purpose is three phase of focus on this one, three phase and four wires, which is 440 volt for over 22, from which either three phase 440 volt or single phase 22 to 20 voltage supply to consumer may be provided. Here are some advantages and disadvantages of the AC electric power. For the advantages of it, the power can be generated at high voltage as there is no commutation problem. The voltage can be conveniently stepped up or stepped down. The high voltage transmission of AC power reduces losses, which is not which is better than the DC transmission. Here's some problems or disadvantages. Problems of there's problems of inductance and capacitance exist in transmission lines. There's a skin effect. More uh, more copper is required. Construction of AC transmission lines is more complicated and is costly. So effective resistance of AC lines increased. As you know, yeah, the skin effect that will lead to if we have a high skin effect, that will affect the resistance of AC transmission lines. The skin effects, which is the is how you calculate it, how you know the skin effect is the density of the volume of material in comparing with the standard like material, comparing the density of the standard mass over the volume of the material. Here's some of the advantages of the DC power. It requires only two conductors, no problem in inductance or the capacitance. For the same load sending end voltage, the voltage drop in DC transmission is less than a transmission. Uh, there is in this one, a DC line has less corona loss and reduces interference with the communication circuits. There is no problem of system instability so common, which is common in AC transmission. Disadvantages of the DC transmission, you can go over these guys already. Of the DC transmission, I'm gonna talk about the disadvantage here. The generation of power high DC voltage is difficult due to commutation problems. Step up and or step down transmission of DC voltage is not possible in equipment like transformer, which can be done in AC transmission. Here is the long distance power transmission. Uh, using alternating, which is AC. Using AC is complicated by inductance and capacitance of the line. If we need to satisfactorily do this operation, it's necessary to balance the lagging inductive volt amperes of line. We can go over these guys and study this. Focus on the natural load. Here's the material that's the material for conducting electric power should have at these properties: high electrical conductivity, low cost, low specific gravity, high tensile strength, for the commonly used materials conductors are copper, aluminum. This is what mostly used. And here's some sources I used. Here's some practice problem. The highest transmission voltage in the world now is 750, which is B. In modern power station, the range of distribution voltage is 110 to B, 110 to 33 kV. In long transmission lines, we move away from receiving end. The reflective component of the voltage is gonna decrease. Shunt capacitors, as compared to synchronous condensers, have uh, low losses. And here is the source of the question. And thank you very much for listening.